Welcome, folks, to our exciting webinar today, which is on 13 ways to avoid a raster disaster. So, Dave, do you recognize some of these movie posters?
I admit that I am old enough to recognize some of them.
Yes, and I am as well, just barely. I was like a little kid, probably shouldn't have been watching some of these when I was watching them. But we had some fun with this. We also found a special font that is called Raster Disaster. If you search online, you can find that. And we're going to have a little bit of fun. And you know, one thing I was thinking about is that really we're probably overusing the word disaster here today, because most of these aren't really disasters. They're more like inconveniences or annoyances.
Yes, I think we've gotten pretty good in our raster handling, so we've gotten rid of most of the actual true disasters.
Yes, that's right. So today is really a number of ways that you can kind of minimize your annoying raster life experiences. And so we're going to be going through those. Lastly, I do want to just point out one of my favorite movies that I remember vaguely, a disaster movie spoof. Dave, do you know that one?
I believe that's The Big Bus.
It is The Big Bus. The bus is called Cyclops, named after its one headlight on the front, nuclear powered, and the thing is that there's some terrorist on board that causes it to be unable to stop. So it maybe was a little bit like an early version of Speed, but with a little bit of a funny twist, and an actress that ended up being involved with The West Wing had one of her early roles in there. And so we'll see if anybody out there will tell us that, and at the end we'll acknowledge them. Who was the actress that was in The Big Bus? And that's got Dave thinking. Whoops. So, with that, where's my slideshow? Uh-oh. Slideshow. All right. So who are we? Well, I'm Dale Lutz, and I'm a co-founder here at SAFE.
I'm Dave Campenis, and I'm a product support specialist.
And a long-time raster guy.
Yes. I used to make ortho photos for a living.
Yes. So got a lot of depth of experience here with Dave with us today. And standing by in our somewhere in our palatial offices here at SAFE are Mark Stokes and Dan Eisminger, who are ready to answer your questions, like who was that actress on The Big Bus. Dan and Mark, don't tell him. Dave, don't tell him either. And you can do that, but please, it's an interactive thing. Please submit your questions as we are going along. So a few words about us. This is a never been seen before staff photo that was just taken a few days ago. So all of us jammed in there for the photo, and we're here in beautiful Surrey, British Columbia, where we're into rainy season now. And this is an interesting map of all of our spheres of influence of our resellers worldwide. So that's kind of an interesting Voronoi diagram we have there. But we do have today thousands of hopefully fairly happy customers.
Yes, indeed.
What is FME? We are a product that sits in between a bunch of different types of data. I like to say that we are a product that puts data in its place. We let you move between and across and within these different data types. Today we're focusing almost exclusively up here on the top left-ish at 11 o'clock there on Raster, but we do other webinars on these different kinds of things as well. And I hope you'll see throughout the examples a lot of the different ways that you can bring this integrative, that's a new word maybe, integrative power of FME into new things. So let's go out to the first poll and see if we can figure out if people have ever used FME for raster. So let's see if we can. We'll launch the poll. I had wanted to play music during this time, but let's see. Don't have any music. A lot of folks who haven't used raster and FME. It's been in FME since what, about 2006 or 7?
About that, yeah.
And as Dave was mentioning, it's a little bit harder to find disasters these days because the support is getting very solid and tried and true. So let's let it click over to, we've got I think a definitive vote there. We'll close and share the results. So 10% of you are always using FME for raster, and that's great. Thanks very much, and we hope that you learn a few new things today, and you can probably teach us a few things as well. A full 20% of you almost don't have FME at all. Thanks so much for tuning in. Hopefully you'll see some things that tweak your interest. And a big chunk of you have FME, but not for raster. And they are missing out, aren't they, Dave?
Very much so.
Okay, so hopefully by the end of today you'll have some reasons that you too will want to use FME for raster. So let's go back to my slide view. And you know what? This is my first time using PowerPoint, whatever this is. And there it is. Okay, that's good. All right. All right. So, yeah, if you're not interested or not familiar with FME, we do have a weekly webinar. It's on tomorrow morning with Mark Stokes, who you can ask questions of right now, and Vince Vaughn often is part of that as well. No, it isn't Vince Vaughn. It's Craig Vernon, our good-looking sales guy. So you can attend that tomorrow if you want to. All right. So what could help you avoid a raster disaster? So let's go back to the polls one more quick time. Don't worry, we're not going to poll you too much today. But what are the kinds of things that would not necessarily be a disaster for you, but things that could be an issue? You can select many here and let us know what kinds of things could help you as you work with raster. So is it translating, reprojecting? That's a big deal people do with raster and FME, especially in some niche markets, one of the few tools that can do some of the coordinate systems that niche markets have. Mosaicing, tiling, clipping is one of my favorites, Dave.
Oh, really?
I got a nice clipping disaster pick coming up that I found online last night. So, yeah, translating. So let's take a look. But look at this. Not a lot of people that need to restructure bands and palettes.
Lots on reprojecting.
Right. Sometimes you need to do that sort of stuff, or maybe you have complicated formats. We're going to close the polls there and show the results. So basically a lot of interest across the board, the least on restructuring bands and palettes. But yeah, translation, reprojecting, and mosaic and tiling, that's really the bread and butter of raster, I would say. So now we'll go back here into our, whoops, and keep on going. So this is I like this disaster here, the automated translation poster that was in China somewhere, and here's what the auto translation came up with: translate server error. So that's really informative, I guess. There's more than 50 formats in FME, and if you're going to translate between something, you just pick what you're starting with and where you're going to, and off you go. And so we thought we'd do a quick demo of that. So let me grab an example of translation, which is, whoops, I got to learn how to run FME here, sorry. Right, so I got to just drag that onto here. Whoops, except I need to get onto there. There we go. Drag this onto there. And this is what a workspace looks like that does translation. And I'd say, Dave, that's, as workspaces go, about as boring as they get.
Pretty much.
So we added a reader that was the CDED, which is a elevation model format, added a writer, which was our geotiff, and then connected them, and off we went. And it was done already in really 2 seconds. So if we go and say inspect on this, it brings up our data inspection tool, and I go and I pick the file, and I bring her in, and there it is. And so one thing you do notice is that we have a background map thanks to our friends at ArcGIS Online. If you have an ArcGIS Online account, you can use FME to use ArcGIS Online as your background map. And so you just fill it in here, pick your map, and off you go. And there you can see what where you are in the world. So we are actually right over, whoops,
Austin, Texas.
Austin, Texas. In fact, Round Rock, where I have relatives living.
Okay.
So I'm covering up Aunt Naomi when I do this. But anyhow, her name really is Naomi.
Oh, okay.
So she lives in Round Rock. So anyway, special salute out to our friends at Austin, Texas for giving us data. And there we did a translation, and we can see the results. So that's about as exciting as that gets. And so we'll carry on here, talking about different other kinds of what I call higher end formats. Dave, do you use any of these?
No, thank goodness.
So anyway, Dean does, I know. These are more, these are military formats here. Some of these are for like multispectral data or weather readings.
Yeah, NITIF I've used, NITIF.
Planet, I think, comes from the telco space. And if you want to, you can click on that, and you can see the complete list of all the raster formats, which I've got checked here that FME does. And there's quite a lot, all the way down to GRIB, which I know some people were using to try to figure out who was going to win the America's Cup, because you can...
Oh, the weather maps.
Yes, exactly. So you can do that kind of thing. So that's on translation. Resampling. Resampling is a common raster thing that folks might want to do. And so let's just take a quick peek at a resampling workspace. And it is pretty easy as well. You basically just drop down a raster resampler. Now I'll just show folks how that's done. That's the workspace we had before. I just go out here and I type raster resampler. And there it is. And then I would fill in the parameters and off it would go. So that's how we do things. These blue things in FME are what we call transformers. There's a whole bunch of them, and you can search them and learn about them in here or watch our training. In total, look at that, Dave, 53 transformers to do with rasters.
Yep, and most of them start with the word raster to make it easier.
Yes. So there we go. So I could run this quickly. It isn't going to take too long because resampling's fast. And now we've got our TIFF again, and I'll inspect that, and I'll go and just grab it. Here we go. It brings up a new view for me, and there it is. And so if I get information on this one by selecting it, hop over here, I can see that its properties are it's 400 by 400. The one we did before, if I select it, its properties 1200 by 1200 approximately. So we did do something very worthwhile. Okay, so that was resampling. And reprojecting. What do you think this disaster picture here means, Dave? Is that that's the projection of a hamburger onto the human form?
Okay.
That's what I'm thinking it is. So Dave, what do you want to say about reprojection while I get it queued up?
Well, nice thing about the reprojection in FME is that we have several reprojection engines, so you can pick the flavor you want. Our standard reprojection uses the CS-map reprojection engine. But we also offer the Esri reprojection engine if you have ArcGIS installed. And there's also an available Blue Marble reprojector that you can purchase from Blue Marble and use within FME.
There it is, for example.
Yeah, the nice thing about the reprojection in FME is all of these reprojectors work on raster data as well.
Yes, and so one of the things I've popped up the parameters here. Dave, you're a guy that understands this sort of stuff better. What does this mean here, interpolation type?
Bicubic, and these are the different types of interpolation. Nearest neighbor is the simplest interpolation. It just grabs, when you're reprojecting a raster, you're actually moving the pixels slightly. So when it determines what's going to be in that pixel, when it's trying to figure out what information needs to be in that pixel, the nearest neighbor will just grab the closest center to that and move her in. And that's generally better for DEM data. Bilinear and bicubic take a special type of average of the surrounding pixels and it's a weighted average of the surrounding pixels to get the value of the new pixel. That's better for imagery data. It's not as important with reprojection, but it is very, very important if you're doing any resampling.
Right. I never looked at this, but these same options would be available in resampling.
Yes, they are. I think they're available in all of our raster transformers that actually modify the pixel data.
Right. Right. So we're going to run that. That didn't take very long. And if I open this up, let's take a quick peek how we're doing. And again, grab it. In the Data Inspector here, it should come. And there we are. So this is a different projection. But since we're in the Data Inspector, we're reprojecting anyway to fit the spherical Mercator of the background map. So it's not quite as stunning of a difference. No. But if you don't believe me, we look over here and we see that it's TX83C. So we did something useful there.
Moved it into the 21st century.
That's right. So that's that one. Mosaicing. This is when we bring stuff together. And so this is there's a lot of interest in that amongst the viewers today. So what do you want to say about mosaicing, Dave?
It's a fairly simple process. The way FME does it, it simply takes the first raster in, lays that down, lays the next raster in on top of it, etc. So it's a simple lay-down mosaic. So I'm going to take a look. We've got these 4 JPEGs here, JPEG 2000s, that look like they've been tiled. Yep. That's what that says to me. And we're bringing them in, and one of the nice things about FME is that we can do things like this and just say, let's do that, but then we'll say star. I can select many of them, or I can just say, this is a common thing folks do, we'll say star.jpg. That grabs them all for us. And now we're going into the mosaicer. There's an interesting few parameters here. Anything that's worth pointing out, Dave? Again, the snapping type resample, that's basically snaps if you need to. If the images are on slightly different pixel alignments, yes, it will snap them into usually the match the alignment of the first one in to make them all fit into the mosaic. Interpolation type, again, is nearest neighbor. We can probably get away with that in this instance, but again, for the best image quality, you probably want to use bicubic.
If the grids weren't aligned.
Yeah.
If the images like mine are tiled, this wouldn't really come into play.
No, it generally doesn't get used at all.
Right.
Nearest neighbor is also the fastest, so if speed is an issue.
So I'm going to go ahead and run this. One thing to point out as well is if you're mosaicing things that overlap, how does it work? Is the last one in the winner or the first one in?
The last one in is the winner. It's a simple laydown. If you want to do fancier mosaic with clip lines and such, you will need to use a few more transformers like clippers, etc.
Right. So here we've just mosaiced this thing from the JPEGs, and here it comes up. Maybe. What did I do? Oh, I think I goofed it up. So anyway, we'll take a look at that GeoTIFF directly by itself. One thing I wanted to do as well. Oh, there it is. Ah, I was just impatient, Dave.
Oh, okay.
It takes a while because there's actually a lot of data in here.
Yes, there
and
is.
So you can see that we're sort of skewed a little bit compared to the original, which kind of brings us to an interesting discussion. And I wanted to just go back to our snap demo that we never did, actually.
Okay.
It's this one, right?
Yes.
So let me bring this onto Workbench, and it's really related to this idea of mosaicing. So what do we got here, Dave?
Well, actually, it's good that we explained those concepts beforehand because we've combined them to solve a simple problem. So this is coming from actual customer case where they have a bunch of image tiles, and the boss wants a simple overview for the customer so they can see how all the tiles look together. And
yes.
To make it more interesting, he wants it in a lat-long projection because.
Okay, so these were tiles in ECW?
Yes.
And so you run them through a reprojector.
We're going to reproject them to lat-long, we're going to mosaic them together, and then we're going to resample them down to like an overview size because we don't want this huge image because like you saw before, it takes a while to load. We just want something simple that'll show up in an extremely simple web page because I'm not a very good
Dave,
web programmer.
you did some HTML for this. So
very little HTML.
So let's take a look at Dave's web page here. You know, I probably could have done that too. So it's basically, we're just looking at the thing there. So we've just run it, and in our output directory is the overview. Oh, there's kind of a foreshadowing of what it's going to look like. So let's take a look in the overview. And what's the problem here, Dave?
Okay, the problem is you've got these big black triangles in the middle of your image. And that doesn't look very pretty.
No.
And the reason for that is when you reproject the image, it ends up rotating it slightly. Well, rasters have to be rectangular. That's their data structure. So FME fills in those the sort of empty spaces with, by default, black triangles or black data. But when you mosaic them together, these black areas overlay the adjoining image areas, and it looks very not pretty at all.
Yes.
So what we want to do is the best thing to do would be to make that those black areas somehow transparent. So when you lay them beside each other, the underlying image would show through.
So I don't know if the folks saw it there, but what I just did was run it. I attached in FME what we call an inspector to this reprojector so we could see those four images by themselves before they were mosaiced.
Yep.
And they've been moved around a little bit.
Yep.
And there's all these black triangles that wouldn't have been part of the original data.
No, those are actually formed by the reprojection process.
So what's to be done?
Well, there's a couple of ways of setting transparency. What you want to do is set the transparency on the image before the reprojection. That's the easiest way. So if FME sees an image that has the transparency capability, when it reprojects and has all those empty pixels, instead of making them black, it makes them transparent instead. There's two ways of making them transparent. One is to actually convert it into an image with an alpha channel, which is a transparency channel. But that has a little bit of a high overhead because that's an entire channel, 8 bits of channel, to store that in for the transparency information, which in our case is just a simple on-off.
Yes.
But there's another alternative which is called no data that many formats support. So we're going to add a no data, which is a simple on-off channel.
So raster band no data setter?
No data setter before the reprojector, and we're going to set our no data to 0.
Okay.
And that'll set a no data on each band to 0, which eventually works out to black anyway. Now in the output image, it's going to take that output and make it what was black before, make it transparent so the underlying images can show through.
The mosaicer will basically say, if I have two things to choose from, I'm going to not pick the no data.
Yes, it will.
And that's going to heal those tears in the space-time continuum. And see, there you can see it came up nicely in my little inspection thing. We're not seeing these black things anymore that were there. And so now, if we go back here and look at our overview, because we've produced Oh, isn't that nice, Dave?
Yes, it is.
And actually, let's take one last look at our little thumbnail, and it looks healthy too.
Yes, it does.
All is well. So there's a minimal, not really a disaster, but certainly an inconvenience averted by being careful about no data. Again, this was RGB data to begin with.
Yes, it was.
That had no concept of transparency or
yeah,
nothing.
It's from an ECW file, which is a lossy compression.
Yes.
It's a very high quality lossy compression, but it's still lossy compression like JPEG or Mr. SID or JPEG 2000. And because a lossy compression actually changes the pixel values when it compresses, they generally don't have support for transparency or no data.
Yes.
Because no data is essentially set on a sort of fixed pixel value, and if the pixel value changes, that no data goes away.
Yes.
So generally, you find if you read from any of these lossy formats, you will not have a no data or a transparency.
Right. And so by giving it this hint about no data, that allows the rest of this workflow to have that in its toolbox and produce a much more pleasing, nice result.
Yeah. The other thing I would add is that in this case, it seemed kind of straightforward to say, well, let's reproject first and then mosaic and then resample, and that's because that's the way you think of your workflow.
Yes.
But it actually would work better if you mosaic first and then reproject it. Because now you're abutting all of these images together and with no black areas at all, and then you can reproject, and maybe you need the no data setter to give the transparency, or maybe you don't.
But you wouldn't, if you did that, you wouldn't get those gaps in between.
You wouldn't get the gaps, but you would have the black triangles around the outside edges, which may not look as nice. But if you're going into something like JPEG or any other lossy compressed format, it's pretty much what you're stuck with.
So what we'd have done then is deleted that and done the mosaicing first.
Yeah.
Like that. And then we would have taken the results of the mosaic. I wouldn't have this link. I would instead be reprojecting that.
Reprojecting
and then
resampling.
resampling.
Yeah.
And then this thing, for now, let's just disconnect it and leave it lying loose. So if I do all that, we should see in our little thumbnail, we're really off-roading here because Dave and I were expecting to do this.
Yeah. Well, while we do this, I might also add that if you have a lot of images, especially big images like ECW, you may think, hey, the raster mosaic, that's going to create this huge image that is going to take up all my memory. But FME works on a kind of a pole model when it's doing raster processing. So it starts kind of at the end, goes through the process, and finds the information it needs to write each output pixel. So the mosaic actually it creates what would best be called a virtual mosaic.
Right.
So you're not writing this incredibly huge image to the disk or anything and then pulling pieces off of it. It's a logical construct, not a real construct.
So here we see that we did produce a nice image with nothing chopped in the middle, but we got black around the outside. Yeah. And so that isn't that big of a disaster. But if I just slide the old no data setter in, probably anywhere in here.
In front of the master mosaic out.
That's right, the best place?
That's the best place.
And then let her rip one more time. Having not tried this before, we nervously await what's going to happen. This is exciting, isn't it? Watching the log go by, that's a symphony unfolding before our eyes. If I bring this up again, ta-da! Okay, we didn't have that nasty black. So that's I'd say disaster averted, Dave.
Yes, indeed.
So the webinar goes on. All right, so there we off-road a little bit, but hopefully that was useful to all y'alls as we were looking. So that's mosaicing. And these don't have, like we did one where the images were well behaved and they were being sewn together, but they don't have to be well behaved at all. They can be a dog's breakfast of images that you just take a very low resolution one and put it down. Is it first? The poorest one goes first?
Well, no, the best one would go, well, it depends. If you, the first image in sets the tone for all the rest of the images.
Okay, yes.
Although I do believe we might give you grief if they're not the same size in some cases.
I think they have to have the same kind of data model. In other words,
same
you
data
got to
model.
have like
same number of bands. And,
right, you can't mosaic a DEM with a ping image.
Yeah,
but
the first one in sets the tone for all the ones, and all the succeeding ones get sort of modified to
be like that. Yes.
Yeah.
So here we go. The compression, and that this is a pretty good compressed situation here. And so if you want to squeeze stuff down, you can write it out to any of these compression formats. And Dave has hinted at some of these already. But really the kings of the compression world, as far as FME is concerned, are the ECWs and JPEGs.
I would say ECW and JPEG 2000. I know JPEG 2000 not getting a lot of love these days, but it is by far a superior product.
Is that right?
Yeah. Downside is it's probably not as supported by as many viewers. But all the main GIS viewers, I believe, support JP2.
Right, right. And actually, well, we'll just look at this. Okay, yeah. So this is the same one. We're just doing that mosaic, and then all we're doing is outputting it in ECW. And one of the things, I don't think I'll run this because it's not super interesting, but you can control the aggressiveness of the compression here.
Yeah. Yeah, we have 75 is a pretty good compression ratio to start with, but you can crank it up if you want.
Right. So as it's going here, it's kind of telling us its story. It's a little bit more work to do compression.
Yeah, we've gotten a lot better with our ECW writing. Earlier versions created a lot of temporary files in your output folder, which took up a lot of space. We've since got rid of that, I believe, for 2013.
Yeah.
And it's a very good compression. Also, if you're familiar with ECW compression, generally there was a model that if to do small images was free, and to do larger images you had to pay money. FME contains a full compressor, so you can compress unlimited size ECWs, subject basically to the memory on your computer.
Okay. I think this is another one that's quite a big image, and it'll take a little while to show up, so we may not. There it is.
There it is. Yep.
So there it just happened. To give you an idea, how big was this image? Let's just take a little peek. It is, yeah, 5,000 by 6,000, so it's a little bit bigger.
Yeah, wavelet compressed images like ECW and Mr. SID and JP2000 can see decent compression ratios of about 100 to 1.
Wow.
With very little loss of image quality, which is why I like it as a format. But it does mean that if somebody sends you like a 1 gig ECW file, you've got a lot of imagery.
Yes, that's right. That's right. So, that scenario, I know that one of the early scenarios people would do is take an ECW that was big and tile it into geotiffs.
Yes.
And they're going to have themselves a lot of geotiff after
indeed.
they're done with that.
Yeah.
So it would be a disaster if you didn't have enough disk space.
Yes. Or you didn't tile.
Yes. So one last thing, in FME 2014, we're just on the edge of starting to be able to talk about that. I can mention that we have WebP. Have you heard of WebP as a format?
That's the new replacement supposedly for ping, isn't it?
That's Google's donation to the world.
Okay.
And so we do support that, and that's another compressed one that has some interesting properties to it as well. Okay. Ooh, here's a bad clip, and actually clipping is also a penalty in football. I could have, but showing somebody being blocked from the rear isn't as exciting as this. This reminds me, as a young man, my father used to cut my hair, and that's where I learned what the word gouge meant. So anyway, enough on that. So this is the simple kind of clipping. You basically take, this is where we do some integration. We're taking some vectors and combining them with raster to produce stuff that we find more useful.
Yes.
So let's take a look what we have here for a nice clip. So let's go here and here. 6 is clip. Okay, yeah, this is a nice bread and butter clip situation. I'm going to go and run this, and we can talk through it. So we're reading again on ECW, a whole bunch of parks from the city, and we're running them through a clipper. And actually, the one thing we're doing in the clipper is we're saying merge the attributes from the clippers to the clippies. That means that each of these raster pieces knows their original name.
Oh, that's good.
And so here we're doing a little trick where we're saying to the writer, fan out by the clipper name, which was the name of the park. So 22 images came in that had a name, and then we should have gotten 22 files. Now, I haven't actually checked this recently, so let's take a look. Oh, there they are. And so there's all those pieces. Again, we have some no data issues. Yeah, oh, no, that's nice. Make the black border introduced, be no data. Okay, so then if we go here and we say inspect, we'll have clipped these things out, and I'll go and I'll grab all of them. So let me see, Control-A should grab them all. And we'll try bringing them all in here. Yeah, there they all appear.
Yeah, they're nice and transparent.
Nice and transparent, and with any luck, there's the background map, and that sure makes this fun, because now we can kind of zoom in and say, ask ourselves, does that look good? And I think that looks good.
It looks pretty darn good.
Yeah, so that's us clipping, and if we select these, then we can see their properties and know what they were from. So that's a simple clip. That would be is that a 10-yard penalty or a 15-yard penalty? Are you a football guy, Dave?
No, more Formula One myself.
I think that clipping is the same in the NFL and the CFL. So that's always nice. So anyway, that's a clip. Now, we start to put it together. And folks at home, if you want to try going to fme.ly/parks, you can see the result of Dave's fine work here. Should I click it just to see what's happening?
Sure.
We'll look at the result first, and we'll ignore what this is. What is that anyway?
Is that? I don't know, but it looks disgusting.
KFC. It's KFC. So anyway, we'll go there and look at this. It's kind of a mosaic. Oh, okay, here we go. So folks at home could see this if they went to FMELY/Parks. And here is the basically a catalog of this, the same sort of stuff we just did.
Yeah, we took those images and made a catalog of them for a convenient web page form. So you can just look at the parks and get some of the information on them.
And if people are interested, you can look at the source here of what we've done, and this takes a minute or two. Whoa, that's kind of some scary HTML you're writing, Dave.
Well, what I did is some of the new browsers allow you to inline your images into your HTML, which is kind of nice. And basically, it's a binary encoded in a PNG or a JPEG and encoded in the base64 format. So that's kind of nice in that you don't have to have, if you're sending this to somebody, you can just send them the HTML. You don't have to send them a folder full of imagery as well.
So let's take a look at how Dave pulled this off.
Sure
so,
thing.
What do you want to talk us through here a little bit?
Yeah. So we've got two sets of data coming in. We have the orthophoto tiles, and we have the map info park boundaries, similar to what we had to the clipping.
Right.
I run a mosaicer to mosaic the source images together. I set the no data setter to set the transparency, and then I clip each park out. That's similar to what the clipper did.
Yep.
Next thing I do, because this is going in HTML, we really would just want an overview. We don't want the full image. So I'm doing a resampler to 10% of the original size. And the nice thing about that is, by using percentage, all the parks will remain proportional to each other in the HTML file.
Yes, that's clever.
Yep. So you might have to play with that a bit to find one that works well for the big parks versus the small parks.
So that's actually, we never talked about that, but when we're resampling, we have a few different options. You can say I want like 4 meter pixels, or I want 100 by 100, or just reduce it by some percentage if you want to maintain proportion.
Exactly. We give you the choice on which one you need for your purposes.
Okay.
The next thing is we force it to a JPEG, or just force it to RGB24 to make sure it's ready for JPEG. And then we use a raster extractor. Now, what the raster extractor does, it's a bit of a niche transformer, but I find it really handy sometimes, is it takes the raster and extracts the raster geometry into a binary blob attribute based on a format you pick here. So it almost becomes an image file stored in an attribute.
Right. Folks have done this and then written this right to a database, for example,
I believe
as a blob.
Yeah, back in the days when SQL Server didn't support imagery, that was a really handy way of storing your images in SQL Server.
Actually, I remember in the beginning of SAFE, some guys in Australia doing this trick with SDE before, in the earliest of days. And then you can pull out the chips really quick and do stuff with them. So you've got them as blobs. And so
okay, and the next step is the binary encoder. So that we take that binary and blob and we convert it into a base64 encoding, which is just an ASCII renderable encoding of the binary.
And then you put that into this attribute called encoded.
Encoded, yeah.
And this is happening once per image.
Yeah. And then we okay, and I should explain that you have the raster in the attribute, but it still has its raster geometry.
Yes.
So I'm reprojecting that raster geometry to lat long because we want to get the bounds in degrees.
And this is an interesting thing because immediately you extract the bounds. The irony is, it appears as though Dave is reprojecting the whole raster. All we're doing is telling that raster, hey, remember that you should be reprojected if we ever need you someday.
Exactly.
And when the bounds guy comes along, he says, okay, what would be your bounds? And he says, okay, here are the bounds if I would ever have been reprojected. So no work actually took place.
Yeah, if you do anything with rasters where the output is a non-raster data, it goes incredibly quick because we pretty much ignore the pixels.
Yes.
Doing that. We get all the other information about the raster, but the individual pixels we don't do anything with because we don't need them.
So for some reason you wanted the bounds here, gave you these y-mins and because you're putting them into the HTML. And then here's your fine looking HTML.
Yeah, where I insert the bounds and I also insert the image data as well.
So here's how he says image data is going to be base 64, and here it all comes just like that.
Yeah.
Makes that noise even when it does that. Okay, and then you just glue that all together and give yourself a nice big HTML file.
Yeah, with my favorite writer, the text line writer. If you're dealing with ASCII formats, you can write anything with a text line writer.
Yes. So that's Dave's park catalog. There you go, looking at it in the raw form. So let's take a look what's next. Tiling. Now here's a messy job of tiling.
Oh
Wouldn't
goodness.
you say, Dave?
Yes.
That's not good. There's a lot of Dyson work to go on after that. But in general, that's a common thing. You got a great big image, you're going to chop them into little pieces. And so let's take a look how we might do that. So tile, here we go. Well, there's a guy called the Raster tiler.
Yes, indeed.
And so I'm going to run this, and while it's going, we'll take a peek. You just say, how do you want to tile this? Again, you have a few options, and I'm going 2 by 2. And I wrote it out to ping here today. And so there we go. Oh, and what I did was I said, make the output file name be the result of the row and the column concatenated together.
Yes.
And so then I used a fan out here on the file name attribute. That's the file name attribute on the fan out in the properties of the ping writer that I created from that string concatenation. And so if I look here and if I open the containing folder, sure enough, I have some world files I wrote out as well, but there's the pings. And when we go and bring this up in the inspector, let me just go and grab these dudes. And here they come. We should see a nice, yeah, if you saw it, they came in tiles, and isn't that something pretty?
Yeah.
All right, so that's tiling. Usually you do more than 4 by 4 though, I think. Is that fair to say?
Yeah, I mean, most folks tile these days if you've got a big JPEG that you need, or a JPEG 2000 or
Yes.
Raster SID that you need smaller pieces of in formats that for software that you don't support the highly compressed wavelet stuff.
Yeah.
The other common one is to do web map tiling. So you're tiling out for, oh, hey, that's our next one.
Yeah, and that's a nice trend. No, that's perfect, Dave. So yeah, you want to talk through this a little bit?
Okay, most web map tiling servers, so if you go to like Google Map or Google Earth, those images you see are not one big image. Basically what they've done is they've chopped up all their imagery into smaller tile sets. And as you zoom in and zoom out, they also have different tile sets at different resolutions.
Yes.
So it kind of makes a pyramid of imagery. So you've got a lot of blocks at the bottom, you've got less blocks at the top, less blocks, and finally you got one cap block on the top.
Yeah.
And as you move in and zoom in and out and move around in the software, it's constantly feeding these tiles to you. Now, to take your own data and create this sort of tile pyramid structure, we have a process for that.
That's right. I'm going to show the results first, and then we'll go. So folks at home, again, if you want to type fme.ly/tiles2013, if you type that into your web browser, you will see what I'm going to show here. And Dave, I did this myself last night.
Whoa.
Using Leaflet.js. I've never done this. I learned JavaScript, and you know what? It's actually pretty easy. These guys that make Slippy maps are probably overpaid, is what I think, because it's actually some old guy like me can kind of get this to go without too much trouble. But if I zoom in, it's like folks at home, you can probably see the detail coming and going as I zoom in way tight. There you see it, right?
Yeah, you can see this
Isn't
new
that a
tiles
thing of
coming
beauty?
up.
And ironically, it's a piddly bit of again, let's look at the developer source here. To lay this on top of Google Map, an old guy like me can do it. So I just went to leaflet.js. I sort of knew, so there they are. I copied their stuff locally into my own website, and then all you do here is you tell the leaflet, here's, oh, that's the base map, which is actually not a Google map, it's actually a cloud-made map, but a Google map would work too. And down here is this is where my web map tiles are living, right here. And all I do is give it this template. Z is the zoom level, X and Y are the Google numbers, that convention that we've used for this example. So this is an example like that. And so let's go and look. I will not run this one. This one does take quite a bit of time to run. But if we look at the web map tiles, here we go. Whoops, I got to go to here. All right. And the interesting thing really, again, this was mosaicing some stuff and getting the transparency right. We have to reproject the spherical Mercator first.
Yeah, that's a special coordinate system that essentially encompasses the entire Earth at a meter-space resolution.
And here's the magic. We have to indicate what scheme we want to make our tiles.
Yes. There's different schemes of tiling, and we have an FMEpedia
Yes.
page that lays out exactly how those work in graphical form.
That's right. If you go to fmepedia.com and if you search for Google Maps compatible like that, I bet you'll get to that page.
Yeah.
Or search for Web Map Tiler. And so anyway, it ends up producing these various attributes, and then we create our file name using the Google naming convention. And if I just bring that up here, it's basically the zoom level underscore tile column underscore tile row. And that produces us, and I ran this last night, so I think if I say open containing folder, quite a pile of images, all with these funny names at the various different zoom levels. You can see them coming rolling in there.
Yeah, now with the web map tiler, you can choose the zoom levels you want,
yes.
But if you leave it blank, it will do its best to optimize.
Which is what we did in this case.
Yeah.
And off we went. And so then we just have these things. We put them up on a web server with a wee little bit of HTML that even Dale can write. And suddenly we got Austin, Texas looking like it did probably 15 years ago in Raster, because this is an old image. So anyway, that's that. So that was pretty exciting, I think. I had fun with that. All right, draping.
Ooh, this is cool.
Yes. So now we start to do some interesting things, and let's just go and run this thing. Yeah, let's get our draping again. So 10 would be simple drape, and I'm going to take and run this. And Dave, you want to talk through what's going on?
Okay, we're essentially taking contours and creating an elevation model out of them. We're thinning them out a bit, forcing them to 3D by their elevation attribute. We're generating a tin surface from them. Now we're taking that tin surface and we're going to throw it into an appearance adder. But the first thing to create the appearance is we're going to take the orthophoto of that island. If we scroll left there, you'll see it, the orthophoto image, and we're going to clip it to the bounding box of that tin. Currently in the appearance adder, and we're working on improving this, the image has to be have the same bounds as the surface that you're laying it on top of. So we clip the image to make sure it's the same size of the surface. We add that image on top of the surface as an appearance or as a texture, as most people know it, and then we write it out to 3D PDF.
Right. And so if we go ahead and grab that result, so it finished it, I think it's finished. It ran and did its thing there. And I'm just going to bring it up on the Mac here. If I get my, let's see, PDF. No, I want Adobe Reader. Oh, I was there. Adobe Reader. And I opened this recently, so I can probably go to recent file. There it is, called Lanai. Is that an island in Hawaii? Or we should probably go there to see.
Road trip.
Yes. And so now what do? I can bring, whoa, okay.
Yeah.
So as Tiana would say, her Aunt Myrtle could probably use this output.
Yes, indeed.
Because it's a lot of folks don't know that you can write a 3D PDF, but indeed you can. And so that's a simple drape. And so what's our next example was going to be, oh, now we get into some power things, Dave. You want to talk about some of these kind of more powerful things folks can do?
Well, band restructuring, if you get multi-band data, and you need to go into a format that doesn't support it, and some of the crazy military formats have these like 8 or 9 bands in them of all sorts of different information, and all you want is like an RGB overview. You can go in and remove bands that you don't need. You can also recode the bands because they might not actually be coded RGB, and to go into some formats you need to recode them as RGB. You can add bands, and a simpler way of doing that is sort of an alternative to that no data setter is we can convert RGB into RGB with transparency, and that's actually adding a transparency or an alpha band.
Right.
And that we can do for formats that support that. Or if you have an alpha band, say you're coming from PNG and you go into JPEG that doesn't support the alpha band, you can remove it.
Right. So I just ran another one of our sort of higher end things, and this one takes and uses this guy here called the raster to polygon coercer. It's going to basically make a segmented set of vectors based on values in the original raster. What we did here, there's a few things going on. We rounded off, we used a raster expression evaluator to round off to the nearest 25 meters in elevation model, and then we converted it to polygons, and then I used a generalization technique on the resulting polygons, and I said make NURBs out of them. And so that's what we did there, and so we see our results here, and so I'll just turn off the background map, and I'll turn off all this stuff. And so here's the original raster, which was a raster. If I select it, I can see, indeed, I had a raster there. If I click on things, I can see the different values. And so you can see they got elevation values coming there, Dave. Do you see that over there?
Yes, indeed.
And so that's great. And so now if I flip back over here and look at this, now this is a vector thing. And if I click on some of these things, Whoa, you see it kind of highlight there?
Yeah, it's essentially you've created a contour map by what we call classifying the rasters.
Right.
So we've given you a simple technique here to classify your raster data.
So this is 175 meters there, and this one right beside, whoop, that's 2 over. There's the one I wanted. That's 200. So that makes sense.
The 25-meter contour, yeah.
The adjoining ones. So that's one of the more advanced things. What I wanted to also do was show this one here does kind of another interesting example, which especially dedicated to our American friends today. So we're going out and basically reading from Wikipedia. There's a KML file sitting there that is a list of the National Historic Landmarks in Washington, D.C. And where we're reading all those, and I'm just picking a few that are close to the White House, and I'm clipping them to be, I only want the ones close to the White House, and then I'm extracting their Latin long, and here's a wild thing, I'm making a URL, whoops, don't show me yet, I'm making a URL that's going out to our friends at Lizard Tech who have a WMS to grab an image around each of those buildings.
Wow.
So I'm basically lifting image chips off of there, I got 11 of them, and then I'm fetching the image using an an image fetcher transformer, and I happen to know it's coming back as TIFF, so I'm happy. That gives me now a raster, which I was outputting as the full color version. And then to show off, I'm doing some raster math using a formula to make a sepia to kind of just tint all of these. And so if you look at this, I can go into here into an editor and say that the result for the red, or the first band, is going to be this combination of the red, green, and blue from before. Yep. Doing some math pixel by pixel, very powerful. There's if then else's in there and so on. That's making sepia. And so we take a look at the results, and then we can conclude a few things. We'll turn off the images, and here's the images in full color. Are they colorful enough for you, Dave? Or?
They're pretty darn colorful.
And it's nice to see, everything's lining up. So that means Lizard Tech and Esri must talk to each other, or else the world is as it should be, because I do see these background maps lining up. Stuff is in color. And then this is what it looks like when the government shut down. It's all in sepia. And that's the only joke I'm going to make about that, because actually that isn't really very funny. So let's go back to where we were. We were showing off some of the power things. Oh, yeah, and here's just a sampling. You want to pick a couple of these to talk about, Dave?
Oh my goodness, there's a lot to choose from. There's the
what's the most let's just pick one, an obscure one that might be useful for somebody.
Okay, the GCP extractor. That's
wow.
Pretty darn obscure.
Yes.
What happens is some rasters, instead of having a geocoding on the corners, are basically embedded with a bunch of control points. Now, we will use that when we read this raster in, but sometimes you want to extract those control points for other reasons, or you want to set the control points on an image as a form of georeferencing.
Right.
So instead of saying, well, these corners are here, you've got something like an aerial photo, which isn't really properly orthoreferenced to the ground. With the raster GCP setter, which is the extractor's corollary, you can add control points to that image. And then when that image is written out and brought into software that understands GCPs, it will fit that image as best it can to the ground.
Okay, yep.
Now, it's still not as good as an ortho photo, but it's a good way to fit an aerial photo that has not been rectified in any way.
Very good. So, we did this one here already about the numeric raster into vector polygons. We did that. We did our raster math as well. And so now, hill shading is kind of fun, Dave. What do you think about hill shading?
I think it's really neat because it gives you a good way of seeing some of the information you might get as raster, which is most rasters are imagery, but a lot of raster data is elevation data. And normally you've seen before some of the elevation data comes in where it's shaded that the highest elevations are white and the lowest elevations are black, but that doesn't give you a really good picture of what the ground looks like. The hill shader converts that into a surface and then sort of directs light at an offset to give you a rendering of what that would look like almost in the real world if there were no trees or anything on top of it.
So here we are somewhere, I don't know where this is actually, but do you know where this is? I don't know where this is, but we could find out by zooming out. But in any case, this is what the elevation looked like. And now, get ready for it, Dave. Are you ready?
I'm ready.
There's the shading.
Hill shading. Actually, the irony with this background map is you can see that they've actually hill shaded their background map as well.
That's right.
So,
that's right.
Ours is a little bit more dramatic.
It sort of just pops, we would say.
Yes.
Pops right out there.
Yes.
So,
but you can see, I mean, in the background map where hill shading can be a very useful part of putting together a cartographic product.
Yes. I mean, that's what this background map had actually done originally, too.
Yeah.
So where is this anyway?
Quebec, I'm guessing by the names.
Ah oui, ah oui. Rimouski. Oh yeah, okay. So
Yeah,
I never knew where that data set was from before.
the South
So
Shore.
yes, very good. Okay, well we've solved that mystery today. So let's hop back. So that was our hill shading. What do we got left? I think we only got one left. Oh, this is sort of a bonus thing. Some folks might have experience the sorrow of LiDAR that has no color, Dave.
Oh yes, yes, and we have some cool tools that basically allow you to take a raster image that's been georeferenced and use that to color the points in the point cloud that lie underneath that image.
So what I'm doing in this example, whoops, it just came up with the answer, but we read an area of interest. Some of you that have seen our LiDAR webinars have seen this before, but I read an area of interest that's in a design file, a whole bunch of point clouds that had no color. They were, what were these things? X, Y, Z, or Z if you're in Canada or the UK. If you take a look, this is what they looked like. And if I can't easily look at them, but hey, they're text. If I do that, oh good grief, I'm going to be waiting for a long time.
Yeah.
Where's VI when you need it? But anyway, they're text. And so now we're going to take a JPEG that has some color. We're going to clip the JPEG to our area, clip the point cloud to our area, and then use this guy here, which is this the one that our neighbors said we were on BC Bud when we named? Point cloud on
one of them, yes.
Yes, we weren't, but this is a mouthful. And so we're basically set the color off of the image on the point cloud, mosaic it basically into one, and then out we get our answer. And I've got it popped up here. And so there it is. We're zoomed in a funny place. I think we got coordinate system troubles on this point cloud actually. But if I go to 3D, folks at home should be able to see that. Whoops, I don't want to do that. I want to just rotate this baby around in 3D. Here we go. And do you see some? Is it showing up for you there, Dave?
Yes, it is. Yep. So now instead of when you look at point clouds in the viewer, we have a sort of default color map in pretty primary colors. But this actually shading your point cloud by the underlying imagery of the land really gives a better idea of what that land looks like when you're looking at that point cloud in any software.
Right. And so if I grab this and I go into the inspector, yes, the thing has field names. And this is what the data would look like. And if I would set that to X and this to Y and this one to Z, then I think with that I'm okay. And if I would just say star.xyz, this would be the original data with any luck at all. I've never tried this recently, so let's cancel that. Oh yeah, I got a little bit of a problem there. Okay, yep.
Yeah.
I made a mistake there, but that was the original data that just gets colored by Z. So there we go. And that's what it would have been. Oh, and I think I could probably flip that into 3D. But the thing is so much more interesting when it's colored. So we'd rather have that or that. I'll take the color, Dave.
Yes, yes. And the color information, if you're writing back out to a LAS, like a LAS file or any point cloud file that stores colored, so you can go strictly from point cloud to point cloud and color it along the way.
Yes, that's right. So, wow, that's been an exhausting tour. We've got ourselves a whole 7 minutes left, Dave. Let's go back out to the polls one more time and ask these people if they've stayed with us all this time. What capabilities would you use if it was added? So we've got quite a pile of things there, but our developers are always doing interesting things, and we're trying to push the envelope. And so let's launch this poll and see what people say. So the first one there is to have tile mill style cartographic rasterization. And a little spoiler alert, we are working on that right now. So I hope you'll find that interesting. So far 0% have. So thank you. I got a sympathy votes coming in.
They don't give me a vote, so yeah.
So anyway, that's going to let you do Mapnik kind of stuff to in combination with web map tiling, taking rasters, vectors, and beautifully styling them just like those fancy Mapbox guys do. Yep. And maybe MB tiles might be an interesting thing for us to write, which is the Mapbox tile format in SQLite.
And then you could upload it all to Mapbox and
pay them a small bit of money, and they'll distribute your map. They'll serve your maps.
The cloud is where it's at.
Yep. So I'm glad to see, maybe with my urging, I might be skewing it. That seems to be in the lead as far as the things go. We'll just go a little bit longer. I know that lens processing was close to making it this time, but didn't quite make it. So that would be the basic image processing, blur sharpening, and all that stuff.
Yeah, yeah.
Very, very close. So let's call that it and show folks the results. So with my urging, it looks like we're on the right track.
Oh, good.
Very objective poll there. And anything else you want to say about these, Dave?
Well, the raster rubber sheeting and or georeferencing, in a way, we can do this now, just not conveniently.
Right.
You have to, like I mentioned before, you actually have to set the GCPs, save that out to a TIFF file or something to support GCPs, then read it back in and apply those GCPs. So we're trying to move this into a realm where we do it all in one workspace.
Right, right, right. So thank you so much for that feedback. That's very, very helpful to us indeed. And so I think we're ready to kind of wrap her up here. Just a few things as we're beginning to close, and then we'll look and see. Dave, you want to start browsing the questions to find something interesting. And I'm not sure if our esteemed colleagues will tell us. Am I still showing the results?
Cool.
Sorry. There we go. Whoops. Yeah, so in terms of what's coming up, there's an FME Cloud webinar. All this stuff we showed today can be done in a server environment. There's an FME server that people have on site, and these things can run hands-free in an automated way. And very shortly, you can just sign up for kind of a monthly charge or even an hourly charge and run this stuff in the Amazon cloud, and we've got everything all nicely set up. If you're interested in that, November 13th will be the day that we're going to be showing that. In other news, we're planned for it now. We're going to be hitting the road again in April, talk about FME 2014, which will release in early January. We'll be blitzing North America the first couple weeks of April. Hopefully the U.S. government isn't shut down then, because a lot of our customers, I'm sure, would like to attend, although it is free to attend. But they would be on their own time, I suppose. But we'd feed them, and well, all comers get a really good lunch. So if nothing else, come for the lunch. And then we are going to be doing, it hasn't been done for 5 years, an international user conference here in beautiful British Columbia. Mark the dates down. You can go to our, I think, fmeuc.com and indicate you're interested, but registration will start soon. Again, that week of June. We'll have stuff going on basically all week here in Vancouver. 2 days for the main conference, 2 days for training, 1 day for a Vancouver World Tour stop, which is free to anybody. That day would be free.
That's cool.
So even if you only come for that, again, you'll get a great lunch. So that's that. We have our online courses. They're all free. You can go to safe.com/training and go hands-on. We'll give you an Amazon machine to play with. You can also go on demand and basically view a recording of the training class at your own pace. Different sites here to look at. We are on Twitter and other things like that. The blog has recently cranked up, a lot of activity on there. If you haven't seen blog.safe.com in a while, definitely worth seeing. So Dave, we've got 2 minutes to look at some questions.
We've got one cool question, at least it's cool for me. Gerhard has asked us, can you feather the pixel values during mosaicing? As we said before, the mosaicing is pretty much just a lay down mosaic, and even if you clip, it's a sort of overlay lay down.
Yes.
Now feathering, you can in a way. I guess you'd need to use the transparency.
Oh yeah, you can make alpha channels on each of them.
Yeah, and we don't have a really innate capability of doing it now, but with some tricky transformer logic, you could probably get it done.
But you know, we should add that into the mosaicer.
We should.
Like a blender, basically.
A blender, yeah. So you give it a blend distance to, actually that would be good. Okay, you need the PR for today.
Yes,
so,
yes.
Yeah, that's a very good question.
Okay, let's see, anything else that looks interesting? 10-yard penalty for clipping, and plus what's even worse is you lose the run back when you're in American and Canadian football. So that was pointed out.
Okay, Google Maps API, raster tile set. Okay, our problem is our current team ends up taking forever because it spends a long time generating tiles for areas that are in the ocean with no data. Is there a way to clip the set worked onto only valid land areas? Yes, there is. Actually, if you can download a boundary of California,
yes.
Even a rough boundary that's slightly outside the boundary of California would be simpler.
You can buffer it too if you had to.
Yeah, and then you can then clip the input raster before sending it to the webmap tiler.
Yes, and then you wouldn't get tiles for all the ocean.
Exactly.
So basically, the gentleman here basically wants to has a raster of a big area of California, and he wants to tile it, but he doesn't want the ocean involved.
Exactly.
So clip first. I know that if you look for like U.S. states shapefile that's on the internet, that's might be shut down right now, but
Yeah.
but someday it'll be back there, and you can.
And
you
I
can
believe
get
that's
that.
where it's important to set the no data before you do the clip, because the web app tiler, instead of creating a bunch of black tiles, will then ignore the no data area.
I guess, Dave, we're out of time. If any
Oh,
of you have other questions, please write them in. Our questions and answer staff will be hanging around for a while, and Dave and I will kind of snoop in there too as we shut down today. But I want to thank you so much for tuning in. It's always great to have so many people spend an hour with us. We honor your time. We try to, and realize you're very busy, so we really appreciate that. And so until next time, this is Dale Lutz from beautiful Surrey, British Columbia, saying happy FMEing.
happy FME.
And avoid all those raster disasters. Oh, lastly, it was Stockard Channing was the person in Cyclops.
Oh my goodness.
She ended up having an esteemed career in West Wing, among other things.
Yes. And Greece.
Oh, was she in Greece too? Yes, that's right.
Oh man.
So we're a little bit old, and we better stop. Okay, that's it. Goodbye.